training.tv. My name is Margaret. I'll be your broadcast engineer for today. How you doing, HOnza? How's life?
Life is great.
Excellent. Good to hear it. We are very lucky to have HOnza back on with us. Actually, he's going to be on with us the nenext 3 Thursdays, which will be awesome. Today's going to be a really fun discussion about the FileMaker 2025 performance update, which is always super cool. HOnza is the master of figuring out the performance intricacies of FileMaker, and it's always a pleasure having him on to talk about that. He will also be doing some of his more interviews over the next couple of weeks, which will be really fun. Real quick, we do this 5 days a week on 3 different platforms: YouTube, Discord, and Twitch. Feel free to look at our topics. I'm kind of excited to get started, HOnza. So, HOnza, how are we
Yes.
doing this? What are we doing today? And what did the results come out
Well,
looking like?
I'm trying to share my excitement, but for many years, I kept showing how FileMaker remained about the same speed, same fast. No significant changes, and this is actually going to change, or it has changed with the release of FileMaker 2025 significantly. So I'm going to share how, and I'm going to talk about basically three areas. So, what I have here for today, let me start with the overall performance, for which many of you already know that we have a free tool that you can download from our website. It's called Bench Test.
Mm-hmm.
And if you go to freesoftware.com, under tools, you will find both FMBench and Bench Test. FMBench is for benchmarking and finding bottlenecks in your solutions and optimizing them. And Bench Test is for testing how fast your configuration, FileMaker version, whatever is, and comparing it with other configurations. After you run the test, you submit the results and you can compare them with the results submitted by other people. So here are the tests. We have already a few hundreds here. And so this is where you find it. And here is my two fresh results that I performed this afternoon with FileMaker 2024 as marketing says, but technically it's marked as FileMaker 21.1.1 as a client, and 21.1.6, which was released yesterday on a server.
Mm-hmm.
Uh, I intentionally ran it on a not very high spec server because slow server reveals more differences much easier. And It was running Ubuntu 22. And after running this test, I ran the same standard test using FileMaker Pro 2020 and connecting to FileMaker Server 2020-02, also released yesterday on
Mm-hmm.
the same computer. So by just looking at these numbers, you'll see that overall performance is slightly better with 22, but the difference is actually negligible, at least by looking at these charts. But this is also a trap. And this is a trap of performance testing that I have been through many times. And it's quite important to run many tests to pick the valid data out from, and also to run the test isolated. I didn't have enough time to completely isolate my test environment, so I was running this test from my normal work machine during the normal working day on our local network. And by looking at the test here, I revealed there was one odd result. And that was for second time sorting. Uh, as you can see here, I click this chart here. When running this test on FileMaker 21,
Mm-hmm.
it was like many times faster, or it took no time to sort the records, while on FileMaker 22 it took 42 seconds. Although normally sorting records, when you
Hmm.
run it for the second time, because it uses local cache, doesn't take too much time. You can see here that first iteration of sorting took 21 seconds.
Hmm.
This is the odd one, and then every other one took less than a second. When I switch to FileMaker 21, you see that these results are expected. Only the first one taking longer and all others taking almost no time. So,
Interesting.
so there is always something happening with your computer. If you don't completely isolate the test environment, which is almost impossible today because the operating systems are doing background tasks, maintenance, things like that. If your computer decides to do some maintenance task during your test, one specific test at that moment gets
Hmm.
affected and you get an odd result. So let me cheat a little bit on this one result here, and I will put a number that's something that should be there. I'm going to run those tests multiple more times to verify that I get consistent results when I repeat the tests.
Hmm.
But for now, let me copy this one other from the second iteration and put it here to get uh, rid of this odd number. And now when I check the overall comparison again, it will get recalculated. And now it's not so negligible anymore.
Oh, yeah, it's a noticeable improvement.
And just a reminder, in this tool, wider bar means faster. So FileMaker 22 seems to be, if I get rid of that invalid result,
Hmm.
about maybe 10% faster than 21.
That's actually a pretty
Uh,
decent chunk.
I have I have another thing here which I will use now. I instead of using my old results from the old test make pro, I will mark this 21 as a reference result. So any score on the 22 result will now mean how much faster or slower 22 is compared to 21. So now when
Got
I
it.
dive into details, individual tests that I performed, all the green numbers mean FileMaker 22 for that specific test was noticeably faster than FileMaker 21. On the other side, when there is a red or pink number, that means that 22 was slower. Again, uh, it's a test that runs 111 tests. Some take longer, some take less than a second. So we don't really care about those tests that take uh, less than a second or around a second because
Hmm.
those can be significantly affected by external factors. But we care about those which take longer. For instance, this test, finding 90% of 100,000 records by unindexed field, 25% faster than
Whoo!
one.
That's nice.
So there are some good things happening. Uh, this sorting, which is the first iteration, so before caching, twice as fast.
That's awesome.
But what's the most significant and actually expected because that was announced is everything that deals with JSON. And now another reminder, if you were watching Clay Mackler's sessions at Engage or Vienna Calling, he was talking about something like passive and active performance improvements.
Hmm.
Uh, he used the term passive performance improvement as something that you get if you do nothing. So you make no changes to your code, you just install the new version of FileMaker and you
Hmm.
get improvement. That's what he called a passive improvement. And because I made no change to this tool,
Mm-hmm.
no change to how I deal with records and how I construct or deal with JSON. This result actually means that this specific test is a simulation of virtual list. Virtual list is a popular technique that's used for performance improvements by getting data from the server and storing it in a global variable and showing it from the global variable instead of directly accessing the records,
Oh, okay.
uh, which would cause too many uh, requests running to the server and back. And here you can see that without me making no changes, this dealing with thousands records through JSON via calculation got almost twice as fast. So
So, a quick
the
question about
info,
the
sure,
I
go
was just
ahead.
the pass. So this bench test is going to be mostly testing passive performance improvements, right then? Because the file doesn't change.
Yes, exactly.
Mm-hmm.
Uh, well, the bench list is more useful for checking or comparing different
Mm-hmm.
configurations. Like
Mm-hmm.
you have two different servers and you want to find out which one is faster. Uh, it's also, well, it's built in a way that I try to mimic typical FileMaker use. So it's really testing how FileMaker works, although it's significantly affected by some oddities like um, uh, cache uh, uh, cache impact is significantly different depending on how many users are accessing the same server and whether those users are modifying the same or different records.
Okay.
So, so it's still a laboratory test, and it gives you just a clue about, well, this is probably going to work faster. This is probably going to be worse. But you will always need to also test your own app to see how it has impacted. And likewise here, the passive improvement significantly depends on how you use FileMaker and how you use its features. So, for instance, here it shows this is a complex test that consists of multiple operations. I can briefly bring it up. So it's test 12C5. So if I open test, uh, sorry, test 12, C5 here. So it's a test that calls perform script on server. This is the perform script on server that goes to the layout, shows all records, uh, and populates a variable for virtualist with a JSON
Mm-hmm.
through some method. It's actually using a summary field or a list function here. So it's combining the JSON into a string using a list function and then returns the list as a result. And then the calling script takes the result and populates a global variable with the JSON and displays the JSON on a layout before and then I actually have the test finished. So it goes here, uh, goes to layout that shows the virtual list, performs fine, and does refresh, and all that counts into the benchmark. So that it really simulates the whole process of
Mm-hmm.
collecting the records from the server and displaying them to the user.
Got it. Okay.
So out of all this, dealing with the JSON is only a small portion.
Mm-hmm.
Uh, so here I am not measuring the dealing with JSON alone. I am measuring the whole. action or operation that the user would be performing in the real solution.
Got it.
And this whole action, in this case, is 1.8 times faster in 22 compared to 21.
Which is substantial.
Uh, so it's really significant.
Hmm.
Uh, and if you look here, uh, all the other greens here are the second and third iteration of the same test using JSON to populate the virtual list.
Got it.
So, what's quite important here as well is in the past, outcome of my testing was okay, JSON is structured, it provides you with a meaningful, understandable data,
Hmm.
but just simply tab delimited text is much faster to work with as a background data for the virtual list. But here you can see that the tab delimited TDT
Hmm.
is still slightly faster than the JSON, but the difference is already not so significant.
Hmm.
So, so we are seeing a significant change that, and another example is calling passing parameters to scripts.
Hmm.
Um, when you need to pass multiple parameters to a script, what has often been used is just separating those parameters with a correct return, because parsing that was faster than anything else. Some people prefer passing JSON as
Hmm.
parameters because it has a understandable structure. It's self-documented,
Hmm.
but for performance reasons, uh, s- you might prefer just return delimited parameters uh, until 21. With 22, the performance of JSON has got so much improvement that it changes the reasoning for one method over another. So today, with FileMaker 22, I can already recommend passing JSON as a parameter to scripts as probably the best method because you don't get worse performance and you get better readability of the parameters.
Woo! That's a big one. That's a big swap. That's awesome,
So,
actually.
and likewise for the virtual list, the difference between performance of processing JSON compared to TDT, the tab delimited text, is already so small that it does make sense to use JSON in those global variables for the virtual list
Hmm.
because there is no significant performance difference.
Less than a second. Yeah, that's nothing.
And another surprise, which I don't know where it comes from, but it's also interesting. One special test that I included some time ago in this tool is a separate file which I got from Vincent Lunier, which was part of a bug report sent to Claris. It was a horrible database structure with thousands of table occurrences.
Whew!
But what was crazy about it, and I can probably show you in this test.
The thousand table occurrences wasn't the crazy bit.
No, the crazy bit was uh, when I open this test database
Uh-huh.
and show you the relationship graph. It will take some time to show. I have to zoom out.
That's never a good sign. Oh no. Oh no.
And, and this is the crazy bit. You see,
How? How does he develop in that? Oh
but the
no. Oh
but
no.
the point here is
Yeah.
none of these table occurrences is actually being used.
Oh.
The file is opening on a layout that's based on a table that has no relationships.
Okay.
and it just tries to create records in that table.
Okay.
And for some reason, which was actually reported as a bug, this obsolete structure, which just exists but is no way connected to the table, still affects performance of dealing with that table.
Really?
And
Okay.
it also impacts performance of opening and closing this file. And that's the interesting bit with FileMaker 22. Unexpectedly, closing this file is between 1.5 and 2 times faster in 22 than in 21.
Interesting. That's kind of insane. I wonder why. I know they wanted to like make closing the file faster so that if uh the server has to force shut something off that it doesn't accidentally
Yeah.
blow something
So,
up.
so,
But
so
still.
there obviously are some optimizations in FileMaker 22 which we do not know about, which were not made public, but life is getting better.
It
That's the
is.
that's the message. So enough about specific about the overall performance.
Okay.
Let me switch to the next interesting topic, and that's AI.
Yes.
Because one of the things that was actually announced in release notes for 22 is that semantic search should now be performed on the server,
Okay.
and uh, it should also be performed on the server when when the embedding vectors are stored in a related table, not in the current table where you're searching in. So I quickly ran this test. I will quickly show what I used for it. So this is my personal movie database where I have about 1,100 movies.
Whew.
And I added a semantic search so that I can do things like, well, what I have a mood for. I would like to watch a comedy with, well, who's your favorite actor, Margaret?
Good question. Who's the Keanu Reeves? I don't know. Does he do comedies?
Am I writing it right?
I think so. Reeves. I think so. We'll see if that writes the
Oh,
first name correctly.
he's not typically comedian, but this is semantic search, so
Yes.
it will show me it should show me movies sorted by relevance. So even if it's not comedy, at least having Keanu Reeves there should be a reason to score high. So I'll hit enter here, and it's obvious that it's finding me movies with Keanu Reeves.
Mm-hmm.
Not only with canaries, but it's a semantic search.
Mm-hmm.
So I write a request. I have a mood for this kind of movie, and
Mm-hmm.
it's such as the first top 100 movies that I might like to watch right now.
That's cool.
So that's what I used as a testing case. And to run the test in the database, I actually added the embedding vectors into 4 different fields. So I added a container field with internal storage,
Mm-hmm.
another container field with external storage, and I also added a related table for dedicated to embeddings,
Okay.
which is connected through one-to-one relationship, and I copied the embeddings there as well. And then I created the list of 5 random queries,
Mm-hmm.
and I ran those 5 queries um, for as a semantic find using all those 4 different container fields. So I was comparing how local versus external storage,
Mm-hmm.
local table versus related table was impacting the performance. And I ran this in FileMaker 21 and FileMaker 22, connecting to a server over a wide area network. So I was connecting from home over VPN to the office where the
Mm-hmm.
server was running. And so I expected that to have some impact if the search was actually performed on the server.
Okay.
And as you can see here, I ran all these four different methods 3 times in a row. So for each query, I did 3 tests
Okay.
uh, so that I could also see impact of caching and things like that.
Yeah, that makes sense. Okay.
And here are the results. So I have four different charts here.
Yes.
I have made the x-axis the same scale for all of them so that we can see the difference.
Mm-hmm.
So each chart is 3 times 5, so 5 different queries. Each query run 3 times.
Okay.
And the blue is FileMaker 21, green is FileMaker 22. And this time, by a wider bar means slower because it's time in seconds.
Got it. Okay.
So what's quite interesting is in none of these charts there is significant difference between 21 and 22.
No, they're about the same. Okay.
It's actually a little bit slower on the 22 side, but I think the main reason is I'm running extremely fast Mac as a client and extremely slow PC as a server. So FileMaker 22 in these tests being slightly slower can be approved, but not like a significant one that the search is actually run on the server. To have a more reliable proof, I would have to deal with much bigger database or much
Mm-hmm.
bigger result set. So I was searching in 1,000 movies and returning 100 of them as a result.
Mm-hmm.
And so to get bigger difference, I would probably have to return more results and search through 10,000 records or something like that.
Got it. Okay.
What is quite interesting here is the impact of the internal versus external container storage. So this is a reminder or proof or significant notice that if you want to use semantic search, don't store the vector indexes out externally. Because internal storage, you see, I get the result within a few seconds. With
Yes.
external storage, it's taking at least 10 times more time.
Oh, yeah, that's substantial.
So that's a quite important thing to be aware of. Another interesting thing, and now reminder, the structure was that I was running one query,
Mm-hmm.
uh, four different methods,
Mm-hmm.
then those same four different methods again, then those same four methods again
Mm-hmm.
before running the next query. So basically, every test was going from here, query number one, query number one here, query number one here, query number one here. Then again, the next query one here, and so on. Interestingly, the second try was taking longer than the first. Sorry. So the first one, I would probably, yeah. I use annotation tool here. So this was the first. This here was the second, and so on. So this was for third, this was fourth, this was fifth, and the sixth. Uh, we knew from past presentations that uh, FileMaker does have some vector cache.
Mm-hmm.
So when you run the first semantic search, you are likely going to have it slow, but when you run subsequent semantic searches, you are going to get results faster. What's interesting here, it it took me 5 semantic search requests before the performance stabilized and remained the same for all subsequent ones. Even
Interesting.
though even though the first four were for the same query, the fifth one was for a different query, and then again sixth, seventh, and eighth were for the same query,
Hmm.
and so on. And it was consistently behaving the same way with 21 and with 22 because the chart patterns are the same.
Okay, so
So
what is
that's so I can only guess what this means. Maybe when you run the first semantic search, FileMaker starts building the vector index or vector cache, but it takes time before the vector cache gets actually ready for subsequent searches. So maybe if I put a pause between those tests, I will get a different results because I will give the FileMaker server time to build the cache. It's just some food for thinking. I'm definitely going to run more tests and try different things. But the important outcome is don't use external container storage for embedding vectors.
hmm
And there definitely is impact of some kind of caching or indexing of the vectors,
Yeah.
which is significant difference between the performance. Uh, what I'm not showing here, but I can tell you because I discussed that with Claymacle, the way the cache is maintained is that it's session specific. So when you start a session and start working with your database, you get benefits for subsequent semantic searches being faster.
Hmm.
But for a new session, you have to wait again for the first semantic search to build the cache again.
Interesting. I wonder if there'd be a way to like pre-do a cache somehow for each
Or
session.
uh, I'm saying cache, but it's actually an index. So what it's building a server-side vector index
Hmm.
that it works. Uh, the interesting thing when semantic search was introduced a year ago,
Hmm.
in one webinar I was asking that Weichu actually mentioned vector index, but no one mentioned where the vector index is stored. Uh, and uh, and we were asking, okay, is it going to make the database bigger? Is it going to grow the FileMaker file?
Hmm.
Uh, and if it's stored there, how do we intentionally delete the index or rebuild the index?
Hmm.
So the answer is right now in FileMaker 21 and FileMaker 22, the vector index is actually built as needed for a specific session. And when the session ends, the vector index is discarded.
Got it. Okay.
So this was second topic. And the third biggest topic is JSON. And for and for that, I originally started by adding something to the bench test. So I
Hmm.
added this tab called Initiative 24, which refers to my our endeavor to convince Claris to make the calculation engine significantly faster.
Yes.
Which, by the way, if you have not voted for this idea yet, we will be glad that you vote and ask all your friends to vote for it in the Claris community.
Yep.
Uh,
There's
just
yeah,
a
your
quick
session on that was amazing. I'll link it to people. Don't worry.
So, quick reminder, uh, sorry, back. Quick reminder, this is the page where you can vote for it. So you go to Claris Community, or you can find it in our rules.
Okay, not to derail you, Hansa. Have you Googled your name with calculations yet? Because the Google AI is telling me about your initiative 24.
Wow,
So
nice.
Sorry, I saw that. I was grabbing the video we did on it, and then Google
So,
surprised
so,
me.
so you can easily find it through Google, or you can find it on our website, or you can find it in Claris community as an idea called significantly faster FileMaker calculation engine, or you can just type in 24u.sw/i24. Sorry, 24usw.com/i24. And that's a short link to the Initiative 24 article, which we constantly update with more links to other articles mentioning us. And there is also a progress bar here shown. How far are we from getting the idea number one on Claris community, uh, which would be a significant reason for Claris to actually put some focus on it. Okay, back to the calculations with JSON. So with the Initiative 24, what I added here is a method to test specific calculation speed and compare them by running them in one version of FileMaker and comparing by running them in another version of FileMaker. And by testing, comparing 21 versus 22, specifically these calculations, like building a JSON array and then going through the JSON array and extracting values out of it using JSON get element, which this is a static array here of, I don't know, maybe 100 or how many items, and then
Mm-hmm.
going through the array in a loop. And these small numbers here actually show how much faster it got in 22 versus 21. But this was a static test, so specific size of JSON, uh, and only by making the JSON this size, I got the result of 12 times faster compared to 21. Then Clay Michael in his session mentioned, okay, it's actually a factor of the size of the JSON, because the reason why it's fast is that uh, FileMaker, as soon as it parses the JSON into a binary object in the memory, it then reuses that binary object and doesn't have to parse the JSON from text over and over again, which means that the more times you use the same JSON, the more speed improvements you get. So instead of doing this static test, I created another test file recently where I actually calculate the factor, the speed improvements as a factor of the number of nodes created in the JSON. In this test file, uh, I'm actually building a JSON, build JSON here, which has, I'll perhaps run it. I think I'm building it in global variable so I can show you, yeah, JSON. So there's no JSON variable right now, uh, but when I run the build script, yeah, I can debug and run this script briefly. Now let's set the size to be not 0, but 10. So I'm building JSON with 10 nodes. And now you can see what's created in the JSON, that it has, oh, this is size. It should be bigger. And there's still something. I'm missing something weird here. It should have 10 items. But anyway, it's building a two-dimensional bidimensional JSON, which when I try to run it in, I just try to run from 10 to 10, step 10.
Mm-hmm.
And now I should have a JSON with, yeah. So I have a digital JSON with 10 nodes.
Mm-hmm.
When I format it, format elements. So this is what it looks like. So it has randomly numbered elements inside, but the total number of second level nodes is exactly what I asked for. So it's randomly structured, but the number of elements is what I request in the parameter. So in that script that I was running, I can specify loop, how many, what size steps I create, and basically I created a loop when I stepped from 100 to 5,000 elements, and now this is what I got. So uh, you can see that what am I missing here? It's showing only 4 values. I need to probably delete those new ones that I created.
There you
Okay, now I'm back here with the
there you go.
original results. So this chart shows with the increasing number of nodes in the JSON,
Mm-hmm.
how the difference between the performance of 22 and 21 is getting bigger. So, for instance, with 5,000 elements in the JSON, and this orange one is FileMaker 21, and this is time. So it's 15 million microseconds. That's 15 seconds.
Mm-hmm.
While the same thing, building JSON in 22 uh, is here. It's hidden. It's this line, the purple one. So just about 25. So sorry, 2.5 seconds.
That's
So
an
two and a half.
insane improvement.
So 2.5 seconds to build a JSON in 22 and 15 seconds to build the same JSON in 21. So when I limit the maximum size um, and change the scale, sorry, uh, let's see, 1,000. You see that it's not so big difference. So it's 1.5 second versus 6.5 seconds. And when I build a small JSON, just 100 elements, it's about twice as fast. But the bigger the JSON gets, the bigger the speed improvement gets as well.
Which is awesome.
So especially when dealing with large JSONs, which you get from API calls or whatever, uh, the more data you work with in a loop, the more you're going to be happy from FileMaker 22.
Yes. And I mean,
Another thing here, and
mm-hmm.
that's also interesting, as Clay talked about passive and active speed improvement. So what's new in FileMaker 22 is a new function, and it's especially for working with the JSON. It's called JSON parse. So when I loop through here, yeah. So I run this test two different ways. And when I want to test the active improvement,
Mm-hmm.
I explicitly called JSON parse before putting the JSON into a variable.
Okay.
Uh, in this case, in the other case, if I wanted passive improvement, I just got rid of the parsed version, the binary form of the JSON, so that I was simulating the passive improvements. Interestingly, when I check those values and you carefully check where those values are, the passive and active results were almost the same. Actually, the passive ones were even slightly better than the active ones.
Mm-hmm.
And why is that? What do you think?
I hmm. I don't
Well,
I don't
it's
actually know.
it's in the definition of active versus passive. So active improvement means you change the code, but not necessarily change
Mm-hmm.
by applying the knowledge about how FileMaker 22 deals with JSON. The problem with my test is I already had the knowledge when I built this test file. So even without explicitly using JSON parse as a function,
Mm-hmm.
I actually was applying the knowledge and I was writing the code in a good way.
Right. You weren't writing, as someone who was doing it the first time would. Yeah.
And the important thing, and that's quite important takeaway, you can benefit a lot from FileMaker 22 improvements without even using JSON parse a single time. And the main reason is any JSON function, like JSON set element, for instance, any JSON function which returns JSON as a result actually returns the binary form of the JSON. So I can do things like this value one JSON number. Okay, forgot the quotation marks. I get a JSON, and when I
Mm-hmm.
check the JSON parsed state, because in addition to JSON parse, we also got a function to check whether we are dealing with a pre-parsed JSON.
Mm-hmm.
See that I am not using JSON parse here, but I still get a positive JSON parse state, which means that the result of this function is already optimized to apply additional JSON calls on it, as long as it stays in memory.
Interesting. Okay, I did not know that.
Uh, and important is the memory. Clay talks about storing in a variable, but the truth is you don't have to store it in a variable. It just needs to stay in RAM to keep the binary form. I ran a very quick test here, uh, and I created a pre-parsed JSON, then passed it to a script as a parameter. Then in that script, I return another JSON as a result, and I'm checking the JSON parse state of the parameter and the script result. And by running this script, you see both the parameter and the variable which the parameter is stored to is parsed. And when I return the result itself is parsed as well, even before I store it into a variable. So, like while Clay suggests storing it into variable, which is a guaranteed way how to keep it in memory,
Mm-hmm.
passing a parameter to a script and returning a result from a script also keeps it in a memory. So it also maintains the parsed state of the JSON. The only thing that gets rid of the pre-parsed form of the JSON, the binary form, is when you either put the JSON into a field,
Mm-hmm.
because then FileMaker converts it to a string, or when you do anything else that implies converting the JSON to a string. And again, when I try to do JSON parse state of something, I use JSON set element again. This time I can use JSON string. So this is parsed, but as soon as I just add it to a string, which converts the JSON to a string,
Mm-hmm.
that loses the parse state.
Interesting. Okay.
So as long as you keep JSON in the form that it was written by a function that returns JSON as a result
Mm-hmm.
naturally, it gets pre-parsed and it's ready to deal with it in a native way. So when you use the parse JSON and apply the JSON get element to it, it's going to be way faster than if you don't. So let me show you. I can perhaps even get the measurable result this way. If I do microseconds, then oh, I need this first. So I need the JSON in variable, then I'll do very simple JSON get element from that JSON, and then another measurement. So this is 38 microseconds. Okay, next time it's less, but let's do like this. Six microsecond. And now when I remove this,
Mm-hmm.
so I'll keep it in binary form. Okay, it may be too small JSON,
For
but
it to.
yeah. Okay. I have a way. So let's do big array,
Okay.
and let's extract element number 4500.
Okay.
So 8 microseconds.
Mm-hmm.
And when I do, oh, sorry, I forgot to remove the JSON part state so that I deal with the JSON. This is better. So I'm getting 5 microseconds to extract that.
Mm-hmm.
Maybe make it an array first. So 3 microseconds.
Okay.
When I do the conversion to a string,
Holy crap. The six the 686 that like flashed
yeah,
immediately
but it's well, the first one was not
was
relevant.
rough.
But
Yeah.
now I'm consistently getting between 6 and 9
Yes.
microseconds. But if I don't convert it to string,
Mm-hmm. It's
I'm
in the 2 to
consistently
3.
getting between 2 and 3. So
Nice.
even with this very simple
Mm-hmm.
still access to the JSON, I can prove that even without using the explicit JSON parse function, uh, I'm getting faster results. And it's in this specific case, it's still 3 times faster.
That's awesome. That's a fantastic improvement.
So, so again, my main tip is you don't have to worry about JSON parse.
Hmm.
You you have to remember every JSON, every function that naturally natively returns JSON as a result
Hmm.
will by default return it as a pre-parsed binary object, and it remains pre-parsed as long as you keep it in memory. As soon as you convert it to a string, either explicitly or by putting it into a field, you will lose that binary representation, and the next time you want to use it, you have to parse it. The only case when using JSON parse may be useful is when you actually have it as a string and you want to, without any modification, convert it to a preparsed JSON. But again, remember, any JSON function that returns JSON will actually parse it. So even if you apply a set element or JSON format for whatever, all these functions will also parse it. So uh, in one latest newsletter, I was suggesting you could create a custom function
Hmm.
that actually maintains backward compatibility with FileMaker 21 or older, uh, and use a JSON parse function in 22. But if you actually use any other JSON function that returns JSON as a result,
Hmm.
which is backward compatible with previous versions of FileMaker, you will still achieve that you get the explicitly parsed JSON in FileMaker 22 and beyond.
Ah, that's
And
cool.
the last tip here, and that
Yes.
comes from this file again.
Hmm.
Uh, Besides trying passive versus active way to deal with the JSON, I also use two different ways to loop through that bi-dimensional JSON here. First one, and this was a surprise to me, uh, looping through one JSON. So basically, I write a loop here that uses a combined key, and it's always accessing just that original JSON by combining the first layer key with the
Hmm.
dot notation and the second layer key and another dot notation, and the actual it actually has a third level where it always has two values,
Hmm.
one text and one number. And the other method here I used was uh, in the outer loop, I actually extract uh, the inner level JSON object as a separate into separate variable, and then I'm only looping through that extracted sub JSON, I would call it, or the
Hmm.
the smaller JSON object.
Hmm.
So here I am in the outer loop. I am actually going through the main JSON at one level, extracting the objects and then looping through the smaller objects in the inner loop. Based on the announcement and all that, uh, like pre-parsed caching, etc., I was expecting the first one, dealing with one JSON, to be
Hmm.
significantly faster. The opposite is true, and even in FileMaker 21, in this chart, the top sorry, this is building when I make the chart a bit zoomed. So these lines, the are this is still building, so I still need to make it a bit zoomed. So these blue squares is actually looping through JSON within JSON in 2021. in 22,
Mm-hmm.
22 here. And these triangles are looping through one JSON. Okay,
Okay.
sorry. So this actually means that, yeah, I was wrong. So it's very difficult to see that these triangles are both green and red, and these squares are
Blue and green.
uh,
There's
yeah,
a dark blue square that's
yeah,
supposed to be somewhere.
dark blue
Oh,
is here in the bottom.
got it. Okay.
So so in FileMaker 21, it's better to loop through one JSON,
Mm-hmm.
uh, while in FileMaker 22, looping through JSON within JSON
Is actually the
is,
performance improvement?
is excellent here. So it's like with 5,000 nodes, I can loop through them in less, well, this is actually less than a second.
That's awesome. That's substantial. That's a substantial improvement.
So yeah, it's very difficult to express how much I'm excited about what's changed in 22. And uh, as I mentioned, active improvement doesn't necessarily mean uh, manually using the JSON parse function.
Mm-hmm.
It means getting and using the knowledge of how FileMaker 22 deal with JSON and applying that knowledge to write a better code.
No, that which you've given us a lot of today. Thank you. Seriously, HOnza, this is fantastic. If anyone wants to see these JSON speed test results and fiddle with it themselves, is there a way to get this file? Or
Yes, this file is actually mentioned in my latest article about FileMaker 22, and you can download it from there. So
excellent.
if you go to 2 software.com to news, there is a new article called FileMaker 2025, One Giant Leap for the Platform. And when you scroll down to see this chart somewhere, where is it? I think it was in the top somewhere. Yeah, here. So you see three instances of the chart.
Mm-hmm.
And here is the download link to get the file.
Excellent. Ah! Awesome. Thank you so much for coming and presenting on this, by the way, HOnza. This has been absolutely fantastic.
Sometimes it's better to just look at the raw numbers that's presented because the charts as they are overlapping, it's
Mm-hmm.
difficult to see where those lines are. So maybe if I simply go to individual results and I disable this appearance, which seems a little bit buggy, although it's cool in the dark mode. So I can just look for results for the size 5,000, and here I get the actual numbers. So loop through one JSON versus JSON within JSON.
Mm-hmm.
Okay, so it was difficult to see in the chart, but the
Mm-hmm.
actual numbers are showing looping through JSONs within JSON in both versions is significantly faster than looping through one JSON. But the difference between 22 and 21, uh, and if you combine the difference between the versions and difference between the methods.
Mm-hmm.
For instance, if you until now were looping through one JSON in 21, you upgrade to FileMaker 22 and also change your code to loop through JSONs within JSON, then do your math. Sorry, 83268 So you get 15 times faster code.
Took me a second to process that number. 16 times faster code. Oh, that's awesome. That's
So
fantastic.
Lynn is asking whether Claris has met my goal of improving calculations by 24%. No, my goal was not 24%. My goal was 24 times faster. And my goal was so that would be 2,400%.
One of these
Uh, so,
days.
so we're not there yet. And also my goal was to make the whole calculation engine faster. So I consider this the first step. We
Yes.
got JSON significantly faster. And I think if we get to deal with the JSON with at least maybe 15,000 nodes,
Mm-hmm.
I think that one will perform at least 24 times faster compared to 21.
Mm-hmm.
So for that particular area of calculations, we are there, but there is still next steps to do.
We gotta do the rest of the functions. Uh, we'll get there. Seriously, Hansa, thank you so much. These are always freaking awesome. Do you have anything else you want to give to us while you're at it, or are we wrapping up?
Well, I think we can wrap up. As a reminder, we are always here for you to help. So if you have questions, if you have struggles, don't hesitate to go to our website. There is a contact form in the bottom. You can even schedule a free call with me, and I'll be glad to help with anything, not only performance related.
Yes, no, Hans is fantastic. Feel free to go hire him. He is, if it isn't obvious, the man's brilliant. So go take advantage of that brilliance yourself. Thank you so much, Hansa. It's an absolute pleasure. I hope the rest of you have a lovely Thursday, and we will see you again next week, Hansa, with Vince, right? So that'll be awesome.
Yeah.
Cool. All right, everybody. See the rest of y'all tomorrow. Bye-bye.